This little bug next to my finger is something called a psyllid. The common name for these insects is jumping plant lice. If you came across one, you might find it hanging out on a leaf like this, and if you got too close and spooked it, this is the amazing thing it'd do to get away. No other type of insect throws itself into the air quite like plant lice do. Just a month ago, I had no idea what a psyllid was. The main reason people talk about and study them is because they feed on plants and can spread crop diseases. Here's what you might see if you found them. This is the underside of a leaf from a persimmon tree. Here on the left is an adult, and those fuzzy green oval things are the immature nymphs. All that white dust on the leaf and the white frill all around the nymph is wax that they produce. Here's a branch from a holly that's infested with a different psyllid. These psyllids, like many others, don't spread disease to their host. Instead, they cause cosmetic damage. They turn leaf buds into these galls that form around where the young nymphs hide out and feed. Here's one cut open with the tiny orange psyllid nymphs and their little clumps of wax. And when I say tiny, these things are less than 1 millimeter in body length. That's the tip of a mechanical pencil for scale. But psyllids are more than plant-sucking, disease-spreading insects. To me, the most incredible thing about them is how the adults use their hind legs to send themselves front-flipping through the air. There's only been this one scientific study that's been published that describes how they jump. It's by Malcolm Burrows, who you might remember from the hopper video I put out. He showed that they spring their hind legs down, rotating them at the trochanter. This is the same spring-loaded leg segment that spittlebugs and leafhoppers use to power their jumps. Those insects are in the same order as psyllids, Hemiptera. But the most unique thing about their jumps are the front flips. No other insects spin their bodies like these things do. I filmed these two sequences at 14,000 frames per second. The one on the left completes its first flip in 0.0025 seconds at a rate of 389 flips per second, and the one on the right is a little slower, only spinning at 212 flips per second. There's no solid explanation for why psyllids flip like this. It might be because they feed with their heads down, so when they jump, they just launch their body from that same orientation, or it might be to maximize the unpredictability of their escape jumps. And some of them flip a lot, spinning dozens of times, several body lengths into the air. Others only flip a few times before they fan out their wings to stop the rotation and transition into a wing-powered flight. It's pretty spectacular to watch them switch from flipping to flying in midair. There are over 3,000 described species of psyllids spread across 8 taxonomic families. And the only thing that's been published about their jumps was done on 3 of those species in 1 of those taxonomic families. So there's a lot left to study with these things. For instance, all of the shots in this video with the yellow background are a persimmon psyllid, which is in a family of psyllids that hasn't been filmed before. So while I shot this video, I also collected a bunch of other not as nice looking video to use for data collection. So I made this video because I don't think psyllids get appreciated for what they can do. I had no idea. It's pretty incredible to me that a bug that might be in this yard can do a front flip in 0.0025 seconds. Thanks for watching.